With what minimum velocity should the block be projected from left end A towards B such that it reaches the point B, okay, of the conveyor belt moving with the velocity V in the opposite direction. Okay, you can see the conveyor is moving in the opposite direction. Friction coefficient is equal to mu. Now first of all we have to calculate the velocity V naught with which the block is projected with respect to ground. Okay, V naught is with respect to ground. Okay, with respect to ground. So basically with respect to ground, its velocity, initial velocity is equal to V naught. If it just comes or if it just reaches this point B, it means that the mass has stopped at this point. So the final velocity will be equal to 0. Acceleration will be in the opposite direction, which is equal to, this is N, this is mg in the downward direction. So the friction force, that is the friction force will be in the opposite direction. So the acceleration will be equal to mu times g. Okay, in horizontal direction with respect to the ground, it will be equal to mu times g. So initial velocity, we will use the formula v square is equal to u square plus 2as. Now the final velocity is equal to 0, initial velocity is equal to v naught. If you see acceleration is in opposite direction, so it will be equal to minus 2 times mu g into s. The distance that it is traveling with respect to ground is L. So 2 mu g is equal to v naught square. So 2 mu g L is equal to v naught square, or v naught will be equal to root of 2 mu g L. Okay, now this velocity, understand that this velocity is with respect to the ground. If I take with respect to belt, its velocity should be equal to v naught plus v, that is the relative velocity will be equal to v naught minus of minus v. So it should be equal to v naught plus v with respect to the belt. Okay, but since there is no such option, I will assume it to be with respect to the ground, which should give me the answer root 2 mu g L, which is option number B.